Can anyone tell me what we did in the last lecture?
How I2C works?
Yeah, so in last lecture what we saw, the theory part of I2C, how it works, and all the things like it uses SCL and data pins and all the modes of I2C and the register bits of I2C, correct?
Yes, sir.
Yeah. After that, also I did the coding part of I2C.
Yes, sir.
Where I write the code of I2C transmission in interrupt mode from I2C 1 to I2C 3, correct?
Yes, sir. Yes, sir.
Actually, last class recorded was not there in website, right?
No. Actually, on the last class Sunday, you guys are not there, so that's why we cancel the class actually. Okay.
No, I'm talking about the class that we did on yesterday, Saturday.
Okay, Saturday. So through I2C we transferred the data.
So in that I made the coding part about how I2C in interrupt mode works, its callback and all, and I gave you one small task. Correct?
Yes.
Yes, sir.
What was that task? Tell me what was that task?
Like taking two boards and communicating I2C using I2C.
So I told you guys, those who have boards with them, to join their I2C 1 and I2C 3 and run that code which I gave you all. Correct? So how many of you tried?
Sir, I sent in WhatsApp also, sir.
Yeah, so you don't have the board, correct?
Yes, sir, I don't have board.
So you told me that you will use Proteus for that.
Yes, sir, but it's not coming, so that's why that one.
So you should have asked me, no? Sunday also, the class was cancelled, but I told you all guys to ask the doubts if you have any. And I think we had the discussion of around 15 to 20 minutes.
Sir, that time I forgot it. Sorry, sir. I forgot, sir.
Okay, Arithika? You have the boards with you.
I borrowed my friend board actually. So for one day I took. So I told na that I'm facing some issue. So and then I'm thinking. So that board I'm planning to buy. Actually, I placed the order, not yet received.
Okay. And Sandeep and Chaitanya?
Yeah, tried in the Proteus simulator.
Okay. Yeah. So did it communicate it?
No, I2C not yet communicated, but previous one have done. I2C I'm doing
the code which I gave you, that code is perfect and it's communicating fine.
Yeah, it's fine.
So what problem you faced that the Proteus was not able to run the I2C on STM32? Can you elaborate? Sandeep?
Yeah, sir.
You have the board with you?
No, sir.
Okay, so you tried on Proteus or anything else?
No, sir.
Why?
I'll try tonight, sir.
But that task was given on Saturday and it was to be completed on the next day, Sunday.
Yeah, Sunday I was absent, sir. So I thought class is.
You were absent Sunday, but you got plenty of time, around 5 days, correct?
Yeah, sir. But I was busy with some of the interviews. So
Can you tell me how much time it will take to test the code which is already working perfectly?
yeah, sir. Just I need to create the project and.
No,
But for this one,
just
half an
everyone
hour.
just tell me the time. How much time it will take to just test the code which is already perfectly working?
15 minutes, half an hour.
And you did not get 15 minutes in the whole week. Guys, I'm trying to prepare and tell you from last 2-3 classes that you need to put efforts. Otherwise, you will not learn embedded system. Your code will work because I'm providing you with codes and all everything. So that code will work. But until and unless you will try it on your own, at your own side, on the controller, and face some issues and solve it on your own, or you can discuss the issues and then solve it. Until and unless you will not do this, you will not learn it. You will get only the theory parts and the coding which I will show you, but you cannot apply your own on your own things, like if you have to connect some sensor or anything else, until and unless you will try it at your own side. And I don't want any excuses, because I know it takes just 10 to 15 minutes to test a running code. I had already shown you all guys the connection also from the schematic of STM32 board. Still nobody sent me the working video. It's a request from my side. Please try and complete the things which I give you. Only then you will be able to apply it and run at your own side. Okay.
With simulating with Proteus, I don't have that much. I don't know, sir, how to do it.
Just watch the Proteus YouTube video. It's of around 20 minutes. Okay, no issue. One more thing I told you all guys, those who do not have the boards with them, I told you guys to send me the code, the modified code of your own versions, and I think I received only 1 or 2 codes. So can you tell me why it's happening?
Sir, can you repeat it?
In the last class, I told you guys that those who do not have controller boards with them, they can modify my code and create their own version of code and send in the group. And I think I received only 1 modified code. I can understand that you don't have controllers with you, but you have STM32 QID, you can write the code there. Anyway, let's start our class. So in the last class, I told you guys how I2C work, and the interrupt mode code was already shared with you all guys. Correct? Today it was your task that you should send me the video of that where the I2C connection and I2C code was running and transmitting and receiving the data that we were sending. But as no one have completed it, I'll show you and demonstrate it. Fine, I'll just share my screen. Let me know once it's visible.
Sir, what to modify, sir?
the code, the I2C interrupt code which I gave you all, your task was your own version of the using the same library and same. Yes.
HAL library will be same, no sir. Everything
Yes.
will be same.
No, everything will not be same. Code structure will be same. But the logic that we used there, that can vary from person to person. And that was the task given by me to you, all of you. At least create your own version of it. If I give 10 people to write a code, all of them, the 10 people of them will write the code and it will be working fine. But all of them will be having different logic. And that's what I was expecting that you will give me. And I can know what logic implementation you can do on the simple programming. But anyhow, let's just forget it. I'll show you guys how that I2C code is working. So I'll take you once again to this code. What we did, we initialized two I2C, I2C1 and I2C3, correct? I2C1 was master and I2C3 we created as slave. Right?
Yes, sir.
Then, in this buffer TX data, we store some message that was to be transmitted, like uint TX data, I2C interrupt mode enable. So that data will be transmitted from master to slave. Okay? And to receive the data, I created a buffer, RX data buffer. So TX buffer will transmit the data and RX buffer will receive the data. Same thing we did it when we were studying about UART. TX data was transmitting the data and RX data was storing the data that was received. Okay? So here we are sending I2C interrupt mode enable as a message or as data. So for that, what we did in the user code begin to, we use this HAL library, HAL I2C Slave Receive Interrupt, because we are receiving the data in slave mode. So I2C will work here as slave. And which I2C was configured as slave? Can you tell me?
I2C3.
So I2C3. So here we HAL I2C Slave Receive Interrupt configured I2C3. And which data was to be received? In the received data was to be received in which buffer?
RX data.
So we write there RX data, and I don't know the size of data that is to be received. So I just write there size of RX data. It will calculate the size of data that will be received. Fine.
Yes, sir.
Okay, then in continuous while one loop, we were transmitting the data. So can anyone tell me which I2C was configured as master?
I2C1.
I2C1.
I2C1. So here we use HAL I2C Master Transmit because transmission was done from master and receiving was done from
Slave.
So here for transmitting, we used HAL I2C Master Transmit, configured I2C1. And what is this 0x42?
Slave address.
Slave address of the receiver. So slave address of I2C3 is 0x42. You can configure it anything. Like you can write 1, 2, 3, 4, 5, 6, 7, 8, anything. That will be the slave address of that particular I2C. Okay? And I2C transmission of data takes place in around 7 bits. And for that purpose, we left shifted it by 1. I have already made these things clear in previous class. So
Sir, we need to make the last bit as 0 for writing, right? For that purpose.
yes, yes. You can see here where I2C will be configured. Yeah, you can see I2C addressing mode is of 7-bit. Correct?
Yes.
So as I2C addressing mode is of 7-bit and the data which we are sending is of 8-bit, is a character. So for that purpose, we left shift the data by 1 bit when we are using the normal I2C communication. I also told you all guys that when we will use some particular sensor, then we will have to look into the sensor datasheet. And if the datasheet says that for the reading you will have to left shift or right shift by 8 bit, 9 bit, 4 bit, 5 bit, then you will have to left shift it by that particular bit.
Like LSB should be 0, right? For
Yes.
to write. For to read, what will do, sir?
Just read it. Nothing to be done when reading, because the data that will be received, the interrupt will be triggered only when the data will be at the receiving mode and when the data will arrive. So at that time you will have to just receive it. Either you can receive it 1 by 2 at a time, or you can receive all the data and store it in your buffer, then use it for your own purposes. So here I have written the slave address, and data transmission was done using which buffer?
TX data.
TX data. So here we choose TX data and size of TX data. Correct?
Yes, sir.
Yes, sir. Now we give a small delay, HAL delay 100. So it will continuously transmit this data until the interrupt of receiving or slave of I2C will be triggered and it will receive the data. So is my code complete now?
Yes, sir.
No.
RAC callback.
Yes. In previous class also, I told you all guys that whenever we will receive data in interrupt mode, we will have to create its callback function. So for callback function, we will use user
Sir,
for
I have one doubt.
Yes.
Sir, for polling and DMA also, we need to use this receive callback function.
Yes.
Okay, for every mode.
Yeah.
Okay,
Except when you are using normal transmission. In that mode also you can use the callback function, but it will work without callback function in that case also.
Like in polling?
So it's, yeah, in polling either you can use the callback function or you cannot. It's your choice. So mostly we just don't use the callback function there because it will work without that also.
But for interrupt and DMA, we need to use that one.
Yes. In the UART class, when we were using polling method, do we used any callback function?
Initially, we didn't use, I think.
In UART polling code, did we used any callback function?
No, not used.
No, but in interrupt mode, we used it.
Okay. What is the reason, sir? For interrupt and for DMA using receive callback function?
No, callback function will be whenever you will receive any data, the callback function is needed. But in polling mode, as the CPU is continuously working in that mode, so you don't. If you will not use the callback function, still your data will get to you. But in interrupt and DMA mode, you will have to generate the interrupts and DMA, and that around 90% time the CPU will not be working, as I told you in the first UART class. So for that purpose, in interrupt mode, you will have to use the callback function, because only when the interrupt will be triggered, the CPU will work and receive the data. For that purpose,
so for SPI,
yeah.
For SPI and I2C also.
Yeah. SPI we will see later. First, just concentrate at I2C right now.
Okay, sir.
Okay. So we created a slave callback function, and there also normally we receive the data HAL I2C slave receive interrupt mode. Fine.
Fine, sir.
Okay. Now using the schematic, we did the connection on our board. So what we did, we connected ground with ground, but as both I2C were available on same controller, so we don't need to connect the ground to ground. But if you are using two different controllers, then you will have to connect ground of controller 1 with ground of controller 2. Then we connected SCL pin of I2C1 with SCL pin of I2C3. And again we connected SCL pin, SDA pin of I2C1 with SDA pin of I2C3.
Yes.
Okay, that's the connection which I have written here for your purpose. So CN10 connector CN10 pin number 3 will be connected to connector CN8 pin number 0. And connector 10 pin number 5 will be connected to connector 8 pin number 1, and ground will be connected to ground 1. Fine. I have already connected the pins, so I'll just run this code in my controller and see what's happening here. So what
Sorry,
we do after
same
writing the
controller?
code? Yes, because the controller which I am using, STM32 WB series, the same controller have two I2C on it, I2C1 and I2C3.
Yes. Fine.
Okay, so now we will debug this code. So what will happen? I2C1 will transmit the data and I2C3 will receive it. TX buffer will transmit the data and RX buffer will receive it. So we will go here in the live expression, and where we are receiving the data?
RX data.
RX data. So just write RX data here. You can see nothing is received here because I have not initiated the program right now. Fine.
Yes.
Okay.
Now we are transmitting from here. So I'll just put a breakpoint here. So my code app came here, and in the TX data, what is there? I2C interrupt mode enable.
Interrupt mode enable.
So if this same data will be received in RX buffer, my I2C communication will be verified. Okay.
Yes.
So I'll just remove this breakpoint. So here in the live expression, can you see it in the RX data? I2C interrupt
Yes.
mode
Yes.
enable.
Yes.
It is received.
Yes.
This means our I2C code and connection is verified. It's working perfectly. My master I2C is transmitting the data correctly, and my slave I2C is receiving it correctly.
Yes, sir.
So, any doubt till now?
No.
That was your task. It took me just 10 minutes to demonstrate it. Because that code I have already given you all in the previous class.
Yes, sir.
I'm asking still now. If you have any doubt, you can ask. Or else we will start the new topic today. So everyone understood it? How my master is transmitting the data using I2C and slave is receiving it.
Yes, sir.
I want yes from everyone.
Yes, sir.
Fine.
Sir, There are
Yes.
some other HAL library functions also, like writing the data into register
Yes.
and retrieving from data into register. So that is
Yes.
also implemented by I2C also, right?
Yeah, you can use HAL I2C, transmit it. One second, I'll show you.
Like
HAL
memory transmit.
I2C, one second. HAL I2C Master Transmit, and you will press Control and space, you can see there are multiple I2C master functions there. So we can use any function that is available here. Okay. If you want to use it in polling mode, you can use this. If you want to use it in DMA mode, you can use this. In interrupt, you can use this. If you want the master data to be transmitted in sequential mode, you can use this. Sequential interrupt, you can use this. Also, there are functions like HAL I2C trans receive function, something like that. I'm not remembering it right now.
And
But that
like
you can also use in the same function, both transmission and receiving will be done.
like there is a write function also, I think, in I2C.
No, transmit and receive will be there, but I'll see if write function is there. I think there are some functions, but
Like
write
not
function is
master,
not there.
I2C write,
No,
memory write or something.
yeah, that may be there because there are plenty amount of functions that will be used.
Yes, sir.
You can use any one that you know. There is no such hard and fast rule that you should use only this function.
Yes, sir.
But you should have command on at least one function.
Okay.
So here we have successfully demonstrated our I2C communication. Now I'll close it. I will share this code with you all. Now I want everyone to tell me how does I2C work one by one. I'll start with Sudhir. Can you tell me how does I2C work?
Hello, sir.
Yes, please.
It start with start condition, sir, and
Okay.
it sends data to the like data and the clock.
No, is this how I told you all guys that I2C work and everything about I2C? Did I started with start with, or I told you something before that?
I2C, it is a inter-integrated circuit, and it has
Okay.
two wires communication,
Okay.
and it has data pin and clock pin, sir.
Okay.
And also it have master and slaves,
Okay.
and master gives the instructions to the slave, and slave follows that instruction which the master given,
Okay.
and it is a synchronous communication, sir.
What does synchronous
Because
communication mean?
synchronously it use the clock signals, sir.
Okay. Fine. Ritika, can you tell me?
Yeah, I2C is an inter-integrated circuit where it has the two wires. It is a communication protocol actually. Through I2C communication, we can transfer the data between devices. It has two wires, SDA and SDL. SDA is used for data. It is a serial data, and SDL is a serial clock where it provides the clock between all the in the communication. Which means it makes all the devices in the sync,
Okay.
and so it has a frame frame format like start bit where the communication starts. It
Okay.
during
Just tell me how to configure it using the STM32 QID.
sorry.
How to configure it using STM32 QID if I am
Will
using it as master.
I didn't get you.
If I want to use I2C as master, then how
Okay.
will I figure it in my STM32?
In the STM32 will using a schematic will make assign the pins, like we'll select the I2C as a master, like master and slave,
Okay.
and we'll assign the slave address.
Okay.
In that way we can assign pin numbers
Okay.
to it in the
Fine. Anil, can you tell me how do we write the code for I2C? For master only.
Hello. Yeah.
Yes.
The thing is, for master, we will be selecting for transferring, we will use
Can you
this.
speak a little bit louder?
Yeah, we will be using this transfer TX buffer, and also like we will be giving a specific address for that.
So, is there any specific address that is already available?
Yeah, in between 0 to 127, we can give anything.
Okay, fine. Okay, everyone. So now we will start next topic. That will be SPI. Okay.
Sir, I2C between two boards.
That is already demonstrated here. If you have two boards, similarly, like in this, what we did, we selected first I2C as I2C1 and second I2C as I2C3. Correct?
Yes.
And we connected the pins of I2C1 with I2C3. Now, if
Yes.
you have some controller which have only one I2C on it, in 90% controllers, you will get at least two I2C on the same controller. But if you have only one I2C on one board, in this case, you will need two controllers. The code will be same. What you will have to do at that, the connection will be also same. You will have to connect the SCL pin of I2C of board 1 with I2C of SCL of board 2 and SD of board 1 with SD of board 2. What will change here? You will have to connect ground of board 1 with ground of board 2 also.
Okay.
Okay. And rest all the things will be same.
Like we need to flash two programs, right?
Yes.
Like for transmit, we need to.
Yeah. So transmitting is happening in the while one loop. So what you will do, you will run the code of highlight the transmitting in board 1. Then you will remove the board 1. Then you will run the board of receiving in board 2. And after the code is flashed in board 2, then you will once again connect to the board 1. And as the code is already inside the board 1, it will start automatically and transmission will be done and it will get received on the board 2.
Okay. So
Fine.
from board 2, we need to check the receive buffer, right?
Yes, because the slave board 2 will be slave. So only there the data will be received. So
The
you have to
parameters also like.
the parameters
both
will be
we need to-
same. For both boards, you will have to configure the same parameters.
Like for board 1, we need to configure with master parameters.
Yes. As in this tutorial, you configured for I2C one as master and its setting was different. You configure I2C 3 as slave and its setting was different, correct?
Yes, sir.
Same thing you will have to do this. What difference will be there? Both things will not be done on the same board. So I2C one selection will be, and master selection will be done on board 1 In the another board, I2C1 will be configured as slave.
Okay.
Okay.
And primary slave address we need to give the same as it is, right?
Yes, primary slave address you can configure anything which you want between I think 1 to 50.
In that I2C only we need to configure.
Yeah, and just left shift it by 1 bit because I2C is of 7-bit slave address mode.
Okay.
Okay.
Okay, sir.
Now I think we are good to go to the next topic, that is SPI. So can anyone tell me what does SPI mean?
It's also synchronous full duplex communication.
Please speak one by one. If you all will start speaking at once, I will not be able to hear anything.
Yeah. SPI stands for. It's like a communication protocol. Like it acts like one master or multiple slaves. Like.
Okay. So SPI is serial peripheral interface. So what, am I audible?
Yes, audible.
Yes. So SPI is serial peripheral interface. And what will happen here? Data will be transmitted serially in synchronous mode. What does synchronous mean?
It has clock. Serial clock.
It has clock in it. This communication will be used for short distance communication in embedded system.
Yes.
It was developed by Motorola in around 1980s.
Okay.
Okay. And SPI devices can communicate in full duplex mode. What does full duplex mean?
Two-side communication.
Two-side communication
Both two sides
at the same time. That means it will transmit and receive at the same time. This type of communication is known as full duplex communication. So SPI is full duplex communication.
Yes.
This also works on master and slave peripheral architecture.
Okay.
So what, similarly like I2C, there will be master and there will be slave in SPI also. And the same thing will be done. Master will send the command and slave will follow it.
Okay.
Okay. But I2C was not full duplex communication. This is full duplex communication. Why? Because I2C was using just 2 pins, SCL and SDA. But SPI uses 4 pins. Write it down if you have notebooks with you. So SPI uses 4 pins, or you can say 4 buses. First is clock, that is serial clock, SCK. Tell me once you are done.
Yes, sir.
So the first pin is SCK, serial clock. So this clock pin, it will be controlled by master device. The master will control it and will use it to configure the slave and to communicate with slave which the master wants to communicate with. Second pin is MISO, MISO.
Yes, sir.
This means master input, slave output.
Yes, sir.
Third pin is MOSI, MOSI.
Yes.
Master out,
Slave
input. So from the name you can see MOSI pin means master out, slave in. So here the data, this pin will be used to transmit data from master to slave. Master out. So master will transmit the data out and slave in. Slave will receive the data. So this pin will be used to transmit data from master to slave. And MISO, master in, slave out. As I have already told you, this is full duplex. So slave will also communicate with master. So MISO pin will use to receive data from slave to master. So master in, master will receive the data from slave using this pin.
Yes.
Okay. So MOSI, master out, slave in means master will transmit the data to the pin to the slave using this pin. MISO, master in, so master will receive the data from slave using this pin. Master out, slave in, and master in, slave out.
Fine.
Okay. Now there are modes in SPI which we can use, like full duplex mode, half duplex mode, receive only mode, and transmit only mode. Sorry?
Another pin.
Oh yeah, so the first pin clock pin, second MISO, third MOSI, and the fourth pin will be slave select pin, SS.
Yes.
Okay. So previously in I2C, the clock pin was used to configure the slave, correct?
Yes.
But here, this slave select pin will be used to select the slave from which master will want to communicate.
Yes.
Okay. So master will use this slave select pin, and this slave select pin will, if we are using multiple slave, then this slave select pin will select any particular slave, and master will communicate with that slave. Fine.
Fine, sir.
Now, in SPI, we use SPI in as 4 modes. First is full duplex mode, which I have already told you, where both transmission and receiving of data will be done at the same time. Second is half duplex mode. So here also data will be transmitted and received, but not at same time. At one time only one thing will be done. Either it will transmit the data or it will receive the data.
Okay.
The third mode is receive only mode. In this, the SPI will work only as receiver. So it will not transmit data in any case. It will just receive the data that will be transmitted to it. And the fourth mode is transmit only mode. Here it will only transmit the data. It will not receive any data.
Okay.
Okay.
Yes, sir.
Fine. Now, there are some functions that we will use in SPI. Like UART and I2C, SPI will also work in 3 modes. Blocking mode, that is polling mode. Non-blocking mode, that will be interrupt mode, and DMA mode.
Okay.
Okay. You can use any mode, but I prefer interrupt mode because it will there my CPU will get maximum rest.
Yes.
Okay.
Now, this SPI, its speed will be faster than I2C. Why?
Because of separate slave select line.
Yeah, because it has separate slave select line. It is full duplex. So in I2C, what was happening? First, it was transmitting the data, then it was receiving the data. So if it take 1 second to transmit and 1 second to receive, so how much time it will take to complete the transmission? 2 seconds. But as SPI is full duplex mode, so in only 1 second the data will be transmitted and received, because both work will be done at the same time.
Yes.
So for that reason, SPI is faster than I2C. The chip select or slave select pin, when you will configure it, this pin will be active low. What does active low pin means?
Zero.
Zero.
Yes.
Zero.
So by default, this pin will be active low. There are things like clock polarity and clock phase in SPI.
Okay.
Just write it, clock polarity and clock phase.
Track polarity, another one, sir.
Clock phase.
Okay.
So these pins will be used to make SPI modes. Like there are modes in SPI: SPI mode 0, SPI mode 1, SPI mode 2, SPI mode 3.
SPI mode 1.
SPI mode 0 to mode 3.
Okay.
So just write it.
Okay.
So if I have to configure my SPI and I decided that my polarities pin will be 0 and the phase pin will be 0,
Okay.
then this will be SPI 0 mode, mode 0. If my clock polarity pin is 0 and phase pin is 1, so what is the value of 0, 1 in binary?
1.
So this will be SPI mode 1. Similarly, if both clock polarity and phase, these pins are high, then what is the binary value of 1, 1?
3.
3.
So this will be SPI mode 3. And if my polarity pin is 1 and phase pin is 0, then the binary value of 1, 0 is
2.
2.
So this will be SPI mode 2.
Like what does it mean, sir?
Yeah, so when you will use some sensors, in its dataset it will be written that this sensor will work only in SPI mode 2 or SPI mode 1 or SPI mode 3. So in that case, when you will configure the program in CubeMX or STM32 Cube IDE, you will have to select clock polarity and clock phase of SPI according to that.
Okay. Like what does it exactly mean? Why it
So-
is defined like that?
It is to sample the data on, like if you want to sample the data on first clock edge, you know clock and its edge when you transmit the data.
No.
Yeah, okay. So when you transmit, have you used logic analyzer or something like DSO,
Like oscilloscope.
oscilloscope? Yes.
Yeah.
So in oscilloscope, you must have seen that when the signals get transmitted, it makes some shapes like a square shape, rectangle shape,
Yeah.
Yes.
like that.
Ramp. Yes.
Okay,
Yeah.
sir. So that is known as clock. So when it's moving from bottom to top, it's rising
Clock
edge.
signals.
When it's moving from top to bottom, it's falling edge.
Okay.
Yeah.
Okay, so if my SPI is, so first I'll tell you about clock polarity. So
Okay.
clock polarity, it just decide the ideal state of clock. So this will decide whether the clock's ideal state will be 0 or 1. That means the default state of clock will be 0 or 1.
Okay.
Now clock phase, that's the important part. So when you transmit data from one part to another part, the data is received as samples.
Okay.
Okay. So like if I am sending you my name CHANDAN, then you will receive in samples like C. I'll transmit Chandan in one string, but you will receive in samples like C, then H, then A, then N, D, A, N. Okay.
Okay.
These are that's not exactly how sampling works, but I'm just trying to explain you so that you can understand it. So the clock phase pin, it decide on which phase of clock the data will be sampled. So if my clock phase is 0, that means the data will be sampled on first clock edge. So the first
Phase
clock,
0, first clock
yeah.
edge.
So the first clock that it will receive, the data will get sampled and on that edge only. If I have clock phase 1, this means the data will get sampled on second clock edge, not on the first clock edge.
Okay.
Okay. So that's all about the theory part of SPI.
Like exactly what does it age means? Clock age.
When you will make some square wave.
Okay.
Okay. And the point that will connect the horizontal with vertical ones, that is known as the edge.
Horizontal line with vertical.
Yes. And that's known as clock edge when you are transmitting clocks.
Okay.
Okay. So that's all about the SPI theory part
Like
of
when to
SPI.
use which mode? Sir, when to use which mode? Like based on which conditions?
No,
Like
no.
based on slave?
Ideally, you will use the mode 0. So there, both polarity and phase will be 0. But in
Okay.
some cases, if you have to use some external sensors, then you will have to read its data sheet, and from there it will be written that this will work in SPI mode 1, SPI mode 2 or 0. So in that
Okay.
case, you will have to configure SPI like that.
Okay.
Does this mode indicate the speed or just sampling?
It's just for sampling, so that the better amount of data and without any error can be received.
Okay.
Okay, so that's all about the theory part of SPI. And tomorrow we will see how this will work on our controller. So tomorrow we will see the coding part of SPI, and I will connect to the controller, and similarly like I2C and UART, I'll demonstrate you how the data will be transmitted and received from master to slave.
If possible, are we doing any practical test with the external sensors to know about this communication?
For that purpose, you will have to purchase external sensor like accelerometer, gyroscope, or something like that.
Okay.
I'll try if I can get some external sensor, then I'll demonstrate to you all. I think I have some external sensor of I2C. Temperature sensor of I2C, I think I have. So maybe in the next class, I can show you.
Okay.
And I will share the code, like how to configure and write the code. But I'll have to check whether I have it with me right now or some student have taken it from me.
Okay.
Okay.
Sir,
Yes.
I have one doubt. With some of the sensors, like we can communicate with both I2C and SPI.
Yeah, you can just search on Google sensor with both I2C and SPI communication
No,
protocol.
sir.
I
No,
think
sir.
Earth technology sensor, temperature sensor, that communicates with both I2C and SPI on the same sensor.
Yeah,
Some
but which one we
accelerometers
need to choose?
that
So
you can just search on Google, and if this will show you the name of sensors.
No, sir. Like we can communicate with both the protocols, right? So
Yes.
which one we need to choose? Like it will be based on
It
application
will,
or
it will depend on your application. If you want that my 2 pins will be used only, then you will have to choose I2C. If you want that my communication should be faster, then you will have to use SPI. If you want the communication to be full duplex, then you will have to choose SPI. If you want that my communications need not to be that much that much fast, then you will use I2C. That will depend fully on your application.
okay, sir.
Sometimes your board have only 2 pins left, and you have the option to use both I2C and SPI. In that case, what you will use?
I2C.
In the case you have plenty amount of pins available on your board, and you want the communication to be fast, then what will you use?
Yeah, SPI.
Yeah, so that depends on your application.
Okay, fine, sir.
Okay, then I just want you all to try this I2C code and demonstrate it on your boards. In next class, I'll write the code of SPI and will demonstrate how this will work on the controller. Fine?
Okay. So, sir, can you illustrate with the registers programming also? Like in the sense, like writing the data into register and reading the value from the register.
Yeah,
using SPI or I2C.
I told you if I get the I2C sensor that I'm talking about, then I'll show you how this will work. Maybe if not tomorrow, then in next Saturday, I'll definitely take this I2C sensor, external temperature sensor, and I'll demonstrate it to you.
Yeah, fine, sir.
Okay. Okay, so if you have any doubt, you can speak, or else we will wind up this class now.
Yeah, hi Chandan, this is Anvesh. Yeah, Chandan, I have one doubt in I2C.
Okay.
Like we have the theory part, like if it is 7-bit address or 10-bit address mode, we can connect based on that address mode, the slaves, maximum count of slaves.
So
they ask like how many slaves you can connect at a time. How can I answer in the interview for this type of question?
Like then the maximum. So one thing is there.
Mm-hmm.
If someone asks you how many slaves we can connect using I2C, this will depend. Theoretically, it's larger.
Mm-hmm.
But when you test it practically, then I think it's limited. It's around, I think, I'll have to check one minute.
Okay, Chandan. Like this type of question, at the time I'm not able to answer properly. That's why I got this question.
Yeah, no. So if anyone asks you, like in using UART, SPI, I2C, what is the maximum number of devices that we can connect?
Okay.
So the answer is same.
Mm-hmm.
Theoretically, we can connect maximum numbers. That exact number will be available on Google.
Okay.
I think it's around 40 to 40, around 42 in UART case.
Mm-hmm.
But practically, you can connect just 14 to 16.
Okay.
In I2C, it's around something like that. But theoretical numbers are greater than the practical numbers. Mm-hmm. What will happen in that case? Like you will have to use jumper wires in the connection.
Okay.
And that use of jumpers will reduce its speed and effectiveness.
Okay.
And that's why these theoretical and practical number gets reduced.
Okay.
Okay, so if
Okay.
you will use soldering,
Mhm.
so you can, what you will do, you will just solder the I2C or UART or SPI pins with together.
Okay.
In that case, the number will increase, but it
Okay.
will not reach the exact theoretical numbers,
Okay.
because still there some connection issues and the gap or layout designs. These things make these exact practical numbers lesser than the theoretical numbers.
Okay. Okay, Chindan, got it.
Okay,
Thank
and
you.
if you want the maximum number, I'll just check on the Google and tell you.
Yeah, theoretically I know, but
Yes.
practically.
Yeah, practically it's not equal to the theoretical ones. What I have tested till now using SPI, I have connected one accelerometer and gyrometer, one temperature sensor, around 7 sensors I have connected using
Okay.
SPI.
Mhm.
So these are these questions are asked in interview to test your working knowledge,
Yes, yes, yes.
to check whether you have worked on these peripherals or you are just reading it from some theory and just elaborating it.
Okay.
So the exact practical numbers cannot be decided. It depends on your PCB, soldering, PCB layout, and all things, and the environment in which you are testing it.
Okay. Okay, Chindan, got the clarity.
Okay.
Thank you.
Okay, thank you.
Yeah.